In this video, we take a look at percent increase and percent decrease. Percent increases and percent decreases infiltrate every aspect of our lives. We see them in the news, on the TV, in the internet, all over the place. Here are two examples or statements where we see a percent increase or a percent decrease. The first statement, the amount of U.S. greenhouse gas emissions increased by 2.9% from 2017 to 2018. College enrollments nationwide declined 2.5%, with community college enrollments seeing the sharpest decline at 10.1%. If you stop and think about it, you really do hear about percent changes all the time. So in this video, we're going to look at how to calculate percent changes, and more importantly, we're also going to look and dissect where do they come from. So let's start by looking at examples when our percentage is known. Example 1. A family wants to decrease their energy use by 15%. If their current monthly electric bill is $450, what will be their new bill if they are successful? A percent increase and percent decrease is calculated in a very similar fashion. In one case, we'll add, and in the other, subtract. For this particular example, we're starting with a bill, and then we want to decrease to get to the next bill. So we always, in our percent increase or percent decrease, we always are going to have a starting amount, if you like. So we'll always have a starting amount, and then we'll have an ending amount. Now, what matters is whether we're increasing or decreasing to get from the starting to the ending. In this particular example, we're going to take a starting amount, and we're going to decrease to get to the ending amount because the family wants to decrease their energy use by 15%. If we decrease by 15%, well, what do we decrease 15% of? Percents never stand alone, so we always have to multiply that percentage by something. And in our case, we're going to always multiply 15% by our starting amount. So to get a decrease, we're going to have this scenario. We'll have a starting amount or a starting bill. We'll decrease by 15% of that starting bill, and that's going to give us our ending amount. So let's fill in the boxes. We know that the current bill or the starting bill for this family is $450. We are then decreasing by 15%. So we're going to multiply 0.15, which is 15% converted into a decimal, times that starting amount, which is $450. That's going to give us our ending amount, but notice the problem asks what will be their new bill. So we are looking for that ending amount. So I'm going to use X to represent that amount that's unknown. Whipping out a calculator, let's complete these calculations. 450 minus, if we take 0.15 times 450, we'll get 67.5. And if we subtract 67.5 from 450, we'll get 382.5. That's equal to X. And what is X? X is representing our ending amount or our new bill. That means in order for the family to be successful, they'll want to have a bill of $382.50 or less. Let's take a look at another example using percent decrease. A grocery store manager observes that this month her store sold a total of 525 gallons of ice cream. This represents a decrease of 10% from last month. How many gallons of ice cream did the store sell last month? Again, we have a starting amount, an ending amount, and we have a decrease going on. So let me set up my scenario right now. It's going to be similar to the last one. So we have a starting amount, and that's always our first box. And now we're going to decrease, so we're going to subtract by 10%. But we take 10% of something and we take 10% of our starting amount. That then gives us our ending amount. So let's see what the problem says and fill in all the blanks. So a grocery store manager observes that this month her store sold 525 gallons. This was a decrease from last month. So in this particular example, notice we don't know how many gallons we started with last month. So in this particular example, X is representing our starting amount. When we fill in the rest of the blanks here, that means 10% of the starting amount can be written as 0.10 times X. We do know in this case, though, our ending amount, which is this month's number of gallons sold. That's 525. It's the same initial setup at the very beginning with our pictures, but what we filled in as far as information makes our problem look very different. In this case, we have X minus 0.1X equals 525. But that's not too bad because this is a simple algebraic equation. X is the same thing as 1X. And so before we do anything, we want to put those two like terms together. 1X minus 0.1X is actually 0.9X or 0.90X. And to finish solving this equation, all we have to do is divide both sides by 0.9. And that tells us what X is. X, using our calculator, is approximately 583.333333. Now, what was X representing in our problem? Go back to the beginning. Notice X was our starting amount. So this represents the number of gallons that we had last month. And if we round that to the nearest whole number, that's 583 gallons. Let's take a look at one more example involving percent increase, percent decrease. A local campground noted that its number of reservations increased 9% this year to 5,780. What was the number of reservations before the increase? I'm going to draw some pictures and set this up in a similar fashion as to what we've just discussed in the previous examples. Remember, we always have a starting amount. So I'm going to have a box that represents my starting amount. Then, in the last example, we decreased, so we subtracted by a percentage. But in this example, it says that starting amount increased, so we increased by 9%. So in this case, I'm going to put a plus sign here to represent an increase. So the starting amount increased by 9%, and so we're going to take 9% of our starting amount, and that's going to give us an ending amount. So it's the same kind of scenario as with the percent decrease, except in this example we have a plus instead of a minus because our starting amount increases. All right, so what's the starting amount? What's the ending amount? If we read the problem a little more closely, we see that the number of reservations increased 9% this year to this number. 5,780 actually represents our current amount, or if we like, our ending amount. And what is unknown is the number of reservations before the increase. So what's unknown is our starting amount. So our equation simply becomes, if we let X be our starting amount, X plus, and then we convert 9%, so 0.09 times our starting amount X equals 5,780. Remember, X is the same thing as 1X, And so we can combine on the left side 1x plus 0.09x and get 1.09x equals 5,780. To finish solving, we simply divide both sides of our equation by 1.09. That tells us that x, which is our starting amount, is approximately 5,302.75229, etc., etc., etc. Rounding it to the nearest whole number tells us that our starting amount is actually just 5,303. And what does this represent? This represents the number of reservations before the increase. This was just a little bit of discussion about percent increase and decrease. Hopefully you can apply these processes as you do your homework. If you have any questions, don't hesitate to reach out.